Good evening once again. Had some thunderstorms last night, and those kind of blew through about 6 in the morning here, and they've pushed off to the southeast U.S. And the reason for those thunderstorms, a lot of warm air and south flow out of the Gulf. And you can see temperatures in that area running about 10 Celsius above normal in the southeast U.S. Temperatures running up to near 80 degrees along the Gulf Coast here. And we saw even 90s in South Texas down there today. So a lot of very warm air on tap, and we've got kind of a complicated pattern here. You can see the northwesterly flow we've been talking about the past few days. That's kind of broken up a little bit due to the formation of this trough over the Pacific Northwest. However, here in Texas and the southern U.S., we're under this west-southwest flow here. So that's what's helping to bring up a little bit more mild air from the southerly latitudes. And embedded in that, you can see a trough over Texas. This is at 12Z this morning. So probably by about now, that's pushed off towards the Alabama and Georgia area, and definitely they're getting some thunderstorm activity out there. There we go. This is the current radar from southeast Alabama. So we've got a bit of a bow echo going on here, and by bow echo we mean this appearance here. So usually when we have bow echoes like this, we look for a couple of severe weather indicators, or a couple of features that could be associated with tornadogenesis. One is going to be leading edge vortices, and we'll tend to see that on this part of the line here. So that would be one area to look for. The other is bookend vortices, and that would be here. Now, of course, you can get vortices anywhere along the leading edge of the line. So however, let's see here. Let me zoom in on this real quick. We'll look at that bookend vortice. And you can see that here there's some very strong reflectivity gradients, unlike what you see up in this area. So that would be immediately one item of concern there. If I pull up the storm relative velocity, you can see we've got a very tight area of very sharp rotation, very strong rotation. So in this area here, let me show you the output of the values. So we're looking at this right here. That's the velocity value where I have the cursor. So right here we have 53 knots. That's going to be inbound since that's negative. And remember, the radar is up this way. So this is going inbound. And here we've got outbound velocities, and that's going to be about 50 knots outbound here. So you can see we've got two different types of circulation. We have one, convergence, right in that area. The other is we have rotation, since those couplets are offset. So what we basically have is convergent rotation. Now, is that going to be a tornado? Well, the diameter on this rotation is pretty wide right now. So I'm reading off down here the diameter, and that's about 3 miles. We have some tighter rotation right down here, about 1.5 miles. So yeah, that's starting to get a little bit into tornado territory right there. And we're also looking at the altitude of the beam right there. So we're about 2,500 feet. That's fairly, or actually it's 1,500 feet. That's fairly close to the radar. So we're getting a very good sample. The radar's right up here, and we're only about 23 miles from the site. So the center, so basically what I'm seeing here is probably a large meso. And then possibly embedded in that could be a rotating wall cloud, could be a tornado on the ground. Of course, I'll leave that to the Weather Service. I'm not going to make a call on that since I have not been watching the storm, but this would be probably the area I'd be looking at. You can see it's crossing into Georgia here, and that's what it looks like on the reflectivity right there. Now, one other thing we would want to do is look at higher tilts, because sometimes the lower scans may not be showing the kind of detail you want to see. So if I go up to 0.9 degrees, I'm seeing probably a little bit tighter rotation up there. It's also an older frame too, but you can kind of use that in your analysis of the severe storm there. I'm just checking real quick to make sure my audio is good. Okay, yeah, let's put the tornado warning on there. Here we go. You can see we've got the previous warning and the next one crossing into Georgia. There it is right there. So we got a tornado warning. This is a radar indicated rotation. And there's one more look at it before we move on. And I guess we can take one quick look at the tops of the storm, because sometimes that'll give you a little idea of where the strongest cells are. So there you go. You got more of a discrete appearance at the higher tilts. This is going to be up at about 10,000 feet. So this can be one way of differentiating the cells you want to focus on. So this would be one to watch right there. So I'm going to set the dot right there. We'll go down to 0.5. And you can see it's kind of embedded in here, but yeah, that's going to be an area to watch. Also, I see a little bit more of a discrete appearance on these cells here, so that would be another area of concern. So now I'm going up to higher tilts, and you can see how it breaks up into that kind of discrete appearance right there. And these cells, they top out at about 36,000 feet. They're not excessively high topped. Okay, and since we're fairly close to the radar, this is a good time to look at spectrum width. And I've always talked about how this is kind of a hard to get product. Now what I'm seeing here, higher values of spectrum width, this may indicate possibly some hail embedded in the core. So let me put a dot right there. So yeah, there could be some different particle sizes in that area right there. Set another dot in this area here. Now also when you have severe weather, when you have a vortex or a mesocyclone or tornado, sometimes the appearance of very strong spectrum width can be an indicator of debris. So that's another thing you have to watch. That could be debris. Again, I haven't really followed this too much over the past few minutes setting this nightly broadcast up, but that would be one thing to look for right there. Elsewhere around the storm, you can see we have this warm air advection wing up to the north. This is where we've got very strong warm air advection, not really hitting the line, but strong enough to create some convection. And then the main inflow into the storm is running kind of like that. And we'll look at that on the SPC analysis. There it is right there, SPC mesoscale analysis, and you can see that southerly flow, a little bit of enhanced southerly winds, 20 knots, feeding right into that storm. And instability, this would be a good time to use mixed layer, because I think this is pretty much south of the warm front. So we got values of 1,000 to 1,500 feeding into that storm. That's fairly stout. Instability. And then another thing we can look for is the storm relative helicity in the lowest kilometer right there. And you can see the values. These are probably being distorted a little bit by the convection that's already going on. What I like to kind of look at is what's going on out in the area ahead of the line. So it's possible when this field is generated, this is a model-derived field, the actual storm may have been back in here. So we don't know for sure, and we would have to do a little bit more analysis on that to see where these higher values are coming from. But this probably is ahead of the storm and showing values of 400 to 650 on helicity right there. All right, let's keep things moving here. And you can take a look at the warm sector right there ahead of the storm. Storms are located right in here. And where's that warm front? Well, we've got 77 there at Key West, 77 north of Tampa, and we see values decreasing a little bit here. So let's see, it's I think we're probably looking at that front in Georgia, maybe something like this. And then we hit the line, and along that, that's probably where we get into the cold front right there. So we'll check that out on the thickness analysis right there. Here in Texas, westerly flow, you saw things clearing out there on the opening video. Southwest winds feeding up into Texas. This is kind of like post-frontal dry air, or post-dry line air. So it's coming from the Mexican Plateau region. But up to the north, in the Central Plains, we've got ourselves a cold front moving south. So you see that there in Kansas. That's a new Canadian air mass on its way south, and 30s and 20s up there. That's going to change our temperatures quite a bit going into the middle of the week here. Out in the western U.S., let's see here, we've seen things improve a little bit with that trough moving out to the west. So things are just kind of cloudy there, and we see a little bit of southerly flow starting to pick up again. But up in Oregon, I see a lot of northerly winds and very cold weather, 30 at Seattle there, 13 at Spokane. So if you follow the wind flow, you can kind of definitely see something going on here. I might be looking for a cold front, maybe pushing south through Oregon and Idaho. In the northern plains, this is going to be under the influence of the new high pressure area pushing out of Canada. You can see pretty much below zero up in that area right there. Then we'll move up to the northeast U.S. They're kind of waiting on the approach of that system from Alabama and Georgia, and we're getting this cool northeasterly flow ahead of the warm front right there, and some of it feeding back towards the new Alberta Clipper system out to the west right there. So overall, very humid, cool air mass up there. This is what we might call maritime polar in the old air mass nomenclature system. Okay, let's go back to our charts here. Let me clear away some of this. Things got kind of messy here. This would probably be a good time to take a look at a sounding. Let's look at Tallahassee ahead of the line. And the first thing we have to look at is the time. We can see 0Z. So that was taken about 1 or 2 hours ago. And we can see what's basically a loaded gun sounding. This is what we would see before a tornado outbreak. Depth of the moisture, about a good 110, 120 millibars. That's about 3,000 feet there. And we've got a cap above that. So that's helped kind of suppress some of the stronger cells into the evening hours. But above that, the lapse rates are not too steep. What we would see in Texas in the spring, we would see that probably leaning over a lot more like that. So when you lift your parcel and clear the cap, you would get a large positive area. So what we have going on tonight actually is a little bit more of a skinny cape appearance here. Now you have to be careful when you're looking at the indices printed up at the top. You can see the Cape is 160, which is pretty low. And what might be the reason for that? Well, they don't indicate how they're lifting that parcel. It's possible what they're doing is they're lifting strictly the surface. And yeah, if you lift that, that looks like about 160 right there. So this is one example of where you have to modify the parcel, kind of figure out what's going into the storm, and then kind of eyeball the Cape. This is where it helps to kind of get used to seeing what kind of Cape is just by eyeballing it. Like this would probably be about 1,000. And that's better than trying to rely on these numbers, because sometimes they can kind of trip you up there. The other thing we're seeing on the sounding here, very strong southerly winds. And you can see kind of a gradual turn here. This is one thing that would kind of limit the storm relative helicity, because we see very little turning. There is some speed shear here going on the way up. So yeah, we're getting a little bit of curvature on the photograph there. But I think most of this is concentrated just in this layer here. And what you see up here, I think that's mostly in the mid and upper level. This is an example of a photograph that is not labeled. I don't really like these very much because they have very limited use. I really like to see these lines labeled with heights. So sometimes you have to roll your own with Rayab or other websites. I think Pivotal Weather does have the markings on their chart here, and we can take a quick look at that. We have to keep in mind that this is model-derived soundings. So I'll click on that and bring up the forecast sounding. So that's going to be a 1-hour forecast here. Run at 1Z for 2Z. Okay, so there's our sounding. It doesn't show the cap too well here. But let's see what the Cape shows on that. See if that's in the ballpark. Okay, surface-based Cape, 1284, so they're getting kind of a different number there. Mixed layer, 1,000, that's pretty close to what we figured out. And most unstable, 1,200. Okay. But the photograph, that's the other thing I wanted to show you here. Because it's the lowest 1 kilometer, that's kind of critical for tornado formation. So there's 0, and there's 1. So we've got a little bit of turning in here. And actually, when we pull out the cell plot here, see right there, that's the cell motion. So relative to the ground, that's from the southwest at about 25 knots right there. So basically, if we sweep that out to the photograph from 0 to the top, which is about 1 kilometer, we get this. And this geometric area corresponds to storm relative helicity. So I guess we probably have some decent values there for rotating storms. That kind of sweeps out a decent area. And the Cape or the storm relative helicity that they're showing, they're in the 289 to 480 range right here. Surface through 1 kilometer, 289. So that's going to be getting up into tornado range right there. So the only real reason we don't have a major tornado outbreak is because there's so much cell competition. We've got a big line, and they're all competing for moisture, and that's going to kind of keep the potential down a little bit. Okay, let me check one other thing here. Okay, yeah, I think that'll do it for now. Let's go ahead and just take a look at what's going to happen over the next 12 hours. This is the high-resolution rapid refresh model here. So you see HRRR. This is really good for convection, unlike the GFS, which is more of a medium-range model. So looking at this HRR, we go through the overnight period. This is about midnight. We just kind of see a broad-scale line across Georgia. And then by dawn, that'll be moving into the Carolinas. And it looks like the tail end kind of comes from about Savannah to Tallahassee and around Apalachicola there. So a little bit of a decrease in the coverage and intensity of the cells. Okay, let's get rid of that, and let me see if I'm missing anything here. Yeah, let's take a quick look at the sounding for Texas, because we're back in the dry air, and one way of getting acquainted with soundings is to use those when the weather is fair, and kind of not just when it's severe, because this can acquaint you with different kinds of air masses that you'll be dealing with every day. So this is the Fort Worth sounding for 0Z. Shows very dry. There's a lot of separation between the moisture and the temperature. And we've also got some pretty warm air aloft right there, so a bit of an inversion at about 5,000 feet right there. So if we had any moisture on the ground, we would probably see a lot of stratocumulus layers here at about 6,000, 7,000 feet. And above that looks like a little bit of humidity. That would give us probably some cirrus up at about 23,000, 24,000 feet. And you can see the winds are kind of westerly all the way up to column. We've got 100-knot winds up here at about 35,000 feet. And just for something random, let's check out Washington. We know that there's been kind of a cold blast through there. Don't have a good sounding for Seattle. That kind of stinks, but we'll try Salem, Oregon. Okay, let me get rid of that. I accidentally pulled out a chart here. Okay, Salem, Oregon. You can see we've got a very cold column. Instead of the temperature line being way out here, it's way over to the left side of the diagram. So this is a very cold air mass, and it's pretty much moist adiabatic all the way up to 400 millibars. And you can see the tropopause is very low. This is down at about 25,000 feet. So when you see this, you know that you're in the bulk, you're in the core of the cold polar air. And it's very, very deep there. So this is where the cold air mass is located in Oregon. So you're going to definitely put the front south of that. And if we go all the way down to, let's see, Medford, Oregon, kind of a similar picture there. So yeah, you would put the cold front even further south. That would be in California, probably about where we had it earlier. Okay, I guess we're about done with these, and we're ready to go into the forecast. Let me get that all set up here. And before I do that, let me just do our frontal analysis real quick. I'll go to the mag.noaa site, and I'll pull up the NAM. I think this time I'm going to use 1,000 through 850 thickness, because I think the air mass near that thunderstorm area in the southeast U.S. is probably a little bit shallow. Okay, so what you can see here, look at that thickness banding right there in North Carolina and Virginia. So that kind of clues you in exactly where that warm front's going to be. So it is going to be across Georgia. We're going to find it around the Charleston area. And then that'll come back into the Gulf like this. So that's the way that part of the front is set up. Then, of course, we have our new Alberta Clipper, or polar outbreak coming south, and there's that right there. And then we go out to the western U.S. And we know that this is in the cold core because we looked at the sounding right there. So we're probably going to put the cold front, maybe something like that, kind of connecting through like that. Then we have this new system out in the Pacific way off to the left edge. Okay. So that's the situation as far as the fronts. Okay, got quite a gang here on the chat. I see we've got Sue and Kevin and Tree, Fred, Alexi, Sarah, Andrew, Mike, Felix, and Eduardo. Okay, hopefully I didn't miss anybody. Kevin. Kevin says the Weather Service reported a sighted tornado in southwest Georgia on that storm we were talking about. Awesome. Yeah, we'll take a look at that Rayab at Glasgow. Let me take a look at that before we move on. So we're going to go up to Glasgow, Montana, see what's going on up there. Yeah, looks like we got some bad data, about 400 millibars. So there you go. See that funny looking tropopause there. But you can see Montana there. Yeah, definitely some cold air. Surface temperatures minus 15 Celsius. That's going to be about 5 degrees Fahrenheit and very cold aloft there. So a lot of cold air lurking just up to the north. And let's go into the actual core of it there. I think that's Flin Flon, Manitoba. A little bit of warm air just above the surface. That's interesting. But very strong frontal inversion down here with temperatures at the surface minus 22, minus 23 Celsius. And there's Edmonton, Alberta. Okay, so there we go. Let's go back to the maps and look at the GFS and run it forward. Okay, so now we know where all the fronts are. We've done a pretty thorough analysis. So they're going to be something like that. There's our MCS. You can see the GFS does not do a very good job resolving the small scale details. And that's why we need the mesoscale models. There's our Canadian front up to the north. And the main front looks like in central Nevada through around the Sacramento area, kind of like that. So this is all very deep polar air mass, and it's making its way south. That's going to be the big change over the next day. So let's run it forward to tomorrow's webcast. So this is Tuesday. The main frontal system that we had in Georgia with the MCS, that's moved up into New York. That's about moved out of the picture. And the cold front coming out of Canada, there it is right there. Very strong cold air advection coming in from the north. And now we have a system coming into California right there. There's our main low just off the coast of San Francisco. There we go. And you can see the 540 line. That's coming south pretty quickly through Wichita and Denver. So our webcast for Wednesday. Continued cold air advection into Texas, and the system is getting hung up in eastern New Mexico and in the Rockies right there. And the Pacific system starting to make its way through Nevada, and the Sierra Nevadas right there. Some snow there in the higher elevations. Then for our webcast on Thursday, kind of a stagnant pattern for Texas, probably kind of cloudy through here. Now we're seeing the system crossing the Rockies. And then for Friday's webcast, now we're seeing things get kind of busy there in Texas. We've got a lot of isentropic lift developing north of this or east of this low here in West Texas. And we're developing some snow there in Oklahoma. Let's see what the Canadian model has got. We'll run this up to Friday's webcast. They've got a much different picture here. See, this is one reason we like to compare and contrast models. So we have more of a Gulf Coast system here on the Canadian model. Let me back that up 12 hours. This is a little bit closer to what the GFS is showing, but the GFS had more cyclogenesis in West Texas. But it did have that strong snow there in Oklahoma. So this looks to me like a little bit of north-south positioning difference and a little bit of weaker cyclogenesis on the Canadian model in this area here. So a little bit of a difference there in the forecast details. Then for Saturday, things look kind of busy once again along the Gulf Coast. GFS going for a frontal system coming through Florida right there. A lot of frontal precipitation north of that. Canadian model is going for the same thing a little bit faster and then clearing that by the same time on Saturday like that. But overall, it's got the same general idea. Then it looks like the GFS is developing a lot of snow and ice in the Carolinas. Canadian model, not really doing that. Goes for a little bit of snow in the Carolinas. And just kind of a transition from rain to snow right there along the coast. So GFS is a little bit more pessimistic. It's going to be... I'll have to write this down and look at that a few days from now and see which model has won out on that one. Let's see, for the 8th, just high pressure across the central and eastern U.S. Attention turns once again to the western U.S. with a new system coming in. And that gets out to the plains around the 10th or 11th, and we've got mostly a central plains system right there. So front is going to be looking kind of like that. And maybe even a bit of a dry line getting started up through this area here. Wednesday the 11th, Great Lakes storm system right there. Pacific getting active once again. Things warming up a little bit in Texas. Lee Side Trough in Colorado. And then for the 12th and 13th, we've got another cold air outbreak. There's the high pressure area there in Montana. That comes south on January 14th and 15th pretty quickly. Pacific getting active once again, and we're getting towards the end of the period here. But overall, it looks like a very strong pattern and prevailing highs coming down south from Canada, and that means cool air for the eastern half of the country and possibly the eastern 2/3. Okay, 34 minutes. Good grief. Okay, I appreciate you guys sticking with that, and let's see here. I think we've pretty much covered everything, so that's about all I got, guys, so I appreciate you watching. I'll be back at the usual time tomorrow, 8 o'clock, and hope you'll join, and thanks for watching. We'll see you tomorrow.